This is Year 13, AS1 Physics 1, and this is past paper solutions to all the questions on Young Modulus and Hooke's Law. So it's from 2004 to 2009. So the first question here, I'll just come in a wee bit so you can see, is from, this previously was on an A2 paper, Module 4, and this is Juno 4. It's now on your AS1 paper. So this is Juno 4 and this is question 1. And this question is about a wire which obeys Hooke's law. It's stretched by gradually increasing force. Figure 1.1 is a graph showing how the extension x of the wire depends on the stretching force F. State how you would use the graph to determine the work done in giving the wire an extension x1. Now you know work is force by distance. And therefore the work done in extending the graph, if you're putting a force on it and it's going a distance, which is the extension, then then you can tell, okay, the work is forced by the distance, but you have to take the shape of the graph into account. And so work is forced by distance. You need force by distance at that x, across from that x value and down to there. So all you need to do is shade. It doesn't matter really which triangle you shade, this one or this one, but this shaded area or this shaded area will give you the same answer. And so state how you would use the graph, calculate the area between the x-axis and the line. And I'm just going to write down W equals a half F times x1. So you would get you would get a mark for saying this and a mark for saying this. It gives you 2 marks. The work done in stretching the graph is called strain energy. Explain why strain energy is regarded as a form of potential energy. So potential energy is energy which is an energy which has a capacity to do some kind of work, and therefore, because the work done stretching the wire is called strain energy, then this, when stretched, the wire has potential or capacity to do work. Your data and formula sheet gives the expression E is equal to a half Fx for the strain energy in E in the wire. Explain why the expression contains the half factor. So your answer there is that F varies linearly, i.e. it's a straight line, with X. And then you have to halve it to give an average force. And that's why it contains a half. It would be good to learn that answer off. They don't really accept the idea about the calculation of the area between the axis and the line and the half there, that it's a triangle, that's half. They don't seem to be that keen, certainly in the mark scheme anyway. So you'd be better learning that there, that F varies linearly with X, and then you have to have it give an average force by distance, because obviously the force is changing there. Part B. The following statement occurs in an advertisement in a catalogue for equipment for outdoor pursuits. The advertisement refers to walking poles, which are long-distance walking sticks, sometimes used by hill walkers. Proper use of a good pair of walking poles can help to relieve the strain on your knees by as much as 30 tons during every hour on the hill. Define strain. So strain, you know, is extension per unit length. Now you could write your equation, but you must write what those things are then. So it's extension over length is strain, but you would have to write down exactly what X was and what L was. Write down an SI unit for strain if strain has a unit. If it does not have a unit, write no unit, and it doesn't have a unit. because extension is measured in metres and so is length, and so metres cancel each other out. From a physics viewpoint, what is wrong with the advertisement? So we look at the advertisement again. Proper use of a good pair of walking poles can help to relieve the strain on your knees by 30 tonnes. Now 30 tonnes is obviously a mass, but strain isn't mass, strain is extension over length. So 30 tonnes is a mass, not a strain. Now, they also will actually allow you to say that tonnes is not a proper unit for strain, which is funny, but they would have allowed that too. A quantity that occurs in the same situation as strain is stress. Define stress. So stress is force acting per unit area. And you could write F over A, provided you say what F is and A is. Write down an SI unit for stress, if stress is a unit. If it doesn't have a unit, write no unit. So you can see force over area there is going to be newtons per metre squared. Or, because it is the same unit as pressure, pascals.